One of the tools we have for statics is that we can reduce a system of forces down to a single force and a couple. We've talked about couples, so we know what a couple is. Here I have an applet that's got three forces, FA, FB, and FC, applied at 3 points, A, B, and C. And then I calculate the equivalent force and couple at another point that I call the about point. So the equivalent force and couple is shown at this out point. So we've really got 3 moments that we need to compute to do this, to find the couple. The resultant stays the same. So as we move this point around, we see that the resultant, that is the sum of these 3 forces on our rigid body, is the same, regardless where I place it. Now, you'll notice there is a point on here where this couple is 0. So I found a point due to these applied forces, the couple is 0. And if I move along the line of action of the resultant, we see that the couple remains to be 0. So all along this line of action of the resultant, the couple stays the same. Even if we do a different point here, the couple is -1, and we move along the line of action, we see it's still -1. So the couple doesn't change if we move our point along the line of action of the resultant. So we could sort of draw parallel lines here, and it's 0 at a point. We can move, again, these forces around and stuff and get different results. I'm going to take these forces and move them opposite. And then if I move this point C up here, and FC, we can see our resultant here. Now we have all 3 forces. If we go to this point, we have all 3 forces pointing to the same point. So all 3 forces, line of actions, cross each other, and we can see our couple is 0 at that point. And if we move off that point, the couple changes. Now if I, in addition, increase my FC value so that my resultant now is 0, we see the couple at that point is still 0, but the couple at any other point is 0 also. That's because, again, the resultant is 0 and all 3 forces are going, lines of actions cross at the same point. So now this body, triangular body here, is in equilibrium. So we can see here all 3 moments are 0 at this point, but at another point they're not. But they cancel out. This is a very useful tool for calculating. We'll see this a very useful tool for calculating reactions at supports.